Hello everyone, let us continue our discussion on second PUC Mathematics paper. So now let us move on to the part C. In that, the first question, which is related on the relations. So we have to check whether the given relation is reflexive, symmetric or transitive. We can clearly see that this relation is neither reflexive nor symmetric nor transitive. If the relation is not reflexive, symmetric or transitive, then we have to give some examples to show that it is not satisfying the given condition. For that, we can take any examples. Now, for my convenience, I am taking this example. We know that 0.5 belongs to the real number. For this real number, 0.1 is clearly not less than or equal to 0.1 whole cube, which implies the order pair 0.1, 0.1 does not belong to the given relation. Therefore, the relation R is not reflexive. Now, let us check for symmetric condition. For symmetric condition, we know that 1 and 2 are the real numbers. For these numbers, obviously 1, 2 will belong to the given relation as 1 is less than or equal to 2 cube. But we know that 2 is not less than or equal to 1 cube because 1 cube is equal to 1. That means the order pair 2, 1 will not belong to the given relation. Therefore, R is not symmetric. Similarly, let us check for transitive condition. For transitive condition, we are taking the example as 9, 3 and 2. These are the real numbers. Obviously, the ordered pair 9, 3 and 3, 2 will belong to the given relation as 9 is less than or equal to 3 cube and 3 is less than or equal to 2 cube. But 9 is not less than or equal to 2 cube, which is 8. Therefore, 9, 2 will not belong to the given relation. Therefore, R is not transitive. So, it is not specific that you have to take the same examples. You can take any of the example, but you have to prove that it is neither reflexive nor symmetric and also not transitive. Now, for the 31st question. For this, let us consider sine inverse of 5 by 13 as x, which implies sin x is equal to 5 by 13. If sin x is equal to 5 by 13, we can find the value of tan x, which is 5 by 12. Similarly, consider cos inverse of 3 by 5 as y. That implies cos y is equal to 3 by 5, which implies tan y is equal to 4 by 3. Now, we want to prove that is equal to tan inverse of 63 by 16. Therefore, consider the formula of tan of x plus y, which is nothing but tan x plus tan y divided by 1 minus tan x into tan y. Now, substitute the value of tan x and tan y, that is 5 by 12 plus 4 by 3 divided by 1 minus 5 by 12 into 4 by 3. If we simplify the terms, numerator will be 15 plus 48 divided by 36 whole divided by 36 minus 20 divided by 36. 36 will get cancelled. We are left with 63 by 60. So this is the value of tan of x plus y. If we shift this tan, we will get tan inverse. X is nothing but sin inverse of 5 by 13 plus y is nothing but cos inverse of 3 by 5, which is equal to, we are shifting this tan, we get tan inverse of 63 by 60, which is the required answer. Now let us move on to the next problem. So we have to express the given matrix as sum of symmetric and skew symmetric matrix. We know that any matrix can be written as sum of symmetric and skew symmetric matrix as one matrix P will be in the form half into A plus A transpose and another, which is a symmetric matrix, and another matrix Q will be in the form half into A minus A transpose, which is a skew symmetric matrix. For that, let us first find A dash or A transpose, which is nothing but we are interchanging the rows and columns, so we get 1 minus 1, 5. If we add A and I transpose, we get A plus A transpose will be 2, 4, 4 and 4. So if we multiply by half, we get 1, 2, 2 and 2. Now let us consider Q as half into A minus A transpose, that is equal to half into, if we subtract those two matrices, we get 0 6, 6 and 0, which is nothing but 0, 3, 3 and 0. If we add these two matrices, we must get back to the minus 6 and here we get minus 3. If I add these two matrices, P plus Q will obviously give us the same matrix, minus 3 and 0. So we get back the same matrix 1, 5, minus 1 and which is nothing but the matrix A. Therefore, we have written the matrix A as sum of symmetric and skew symmetric matrices. Now let us move on to the next problem, that is 33. So we have to find dy by dx. This is a parametric form question. For that, first we have to find dx by dt and dy by dt. Then we have to find dy by dx. To find dx by dt, differentiate the function with respect to t. We get a into differentiation of cos is minus sin t plus log of, that is 1 by tan of t by 2. Differentiation of tan is secant square t by 2 into differentiation of t by 2 is 1 by 2. Now let us simplify this. A into minus sin t plus 1 by tan can be written as sin t by 2 divided by cos t by 2. Secant square t by 2 can be written as 1 by cos square t by 2 into 1 by 2. If we simplify this, we get a into minus sin t plus 1 by cos t by 2 get cancelled. So 2 into sin t by 2 into cos t by 2. So this is a half angle formula, a into minus sin t plus 1 by sin t. If we take the LCM, it will be a into minus sin square t plus 1 divided by sin t. Minus sin square t plus 1 is nothing but 1 minus sin square t, which is cos square t divided by sin t. Let us keep it as it is. Now let us find dy by dt. This is a simple one. We just have a sin t. Differentiation will be a cos t. Therefore, dy by dx is equal to dy by dt whole divided by dx by dt. That is a into cos t divided by a into cos square t divided by sin t. A will get cancelled, cos t and cos t will get cancelled. If we shift this to the numerator, it will be sin t divided by cos t, which is nothing but tan t. Therefore, dy by dx is equal to tan t.
In the 34th question, they have given two numbers x and y such that x plus y equal to 60. That means we can write x as 60 minus y. Let us consider some term p that is equal to x into y cube. We already have x equal to 60 minus y. So substitute the value, then we get 60 y cube minus y power 4. If we differentiate this, p dash will be equal to 180 y square minus 4y cube. If we take 4y square common, then we are left with 45 minus y. To find the maximum or minimum value, we consider p dash is equal to 0, which implies we get y equal to 0 or y equal to 45. Y cannot be equal to 0 as they have given two positive integers. Y must be equal to 45. If we consider p double dash, it will be equal to, we are differentiating this function, so we get 360y minus 12y square. If we substitute y equal to 45, then p dash of 45 will be equal to minus 8100, which is a negative number. Therefore, the product xy cube is maximum when y equal to 45. So y equal to 45 means x is nothing but 60 minus y, which is 50. Therefore, the two numbers are 45 and 15. Next question. Question number 35. So we have to integrate the given function. This is from partial fraction problem. First, let us split this denominator. So the factors will be x plus 1 into x plus 2. Consider the term 2x divided by x plus 1 into x plus 2. By using partial fraction method, we can write it as a by x plus 1 plus b by x plus 2. To find the value of a and b, we have a shortcut method, that is substitute x equal to minus 1 in these two terms, that is except from x plus 1. Then we get 2 into minus 1 divided by x plus 1 is kept as it is, minus 1 plus 2 plus, to find b, substitute x equal to minus 2 in these two terms, that is except in x plus 2. Then we get 2 into minus 2 divided by minus 2 plus 1 into x plus 2. So that is minus 2 divided by x plus 1 plus 4 divided by x plus 2. If we integrate this function, we get x plus 1 into x plus 2 dx, that will be equal to integration of minus 2 by x plus 1 plus 4 by x plus 2 into dx. So the integration will be minus 2 log of mod x plus 1 plus 4 into log of mod x plus 2 plus constant c. So this is about partial fraction problem. To find the area of rectangle, let us consider vector AB as well as vector AC. We find these vectors by subtracting the position vectors. Then we get vector AB is equal to minus I cap plus 3j cap minus k cap. Similarly, vector AC will be minus I cap plus 2j cap plus k cap. Now let us consider the cross product of these two vectors, that is vector AB cross vector AC, that is determinant of I cap, j cap, k cap, minus 1, 3, minus 1, minus 1, 2, 1. If we expand this determinant, we get I cap into 3 plus 2 minus j cap into minus 1 plus k cap into minus 2 plus 3, which is nothing but 5 I cap plus 2 j cap plus k cap. If we consider the magnitude of vector AB cross AC, we get root of 25 plus 4 plus 1, which is nothing but root 30. Therefore, area of triangle ABC, that is equal to half into magnitude of vector AB cross vector AC, which is nothing but root 30 by 2 square root. So this is the area of the triangle. Next, to derive the equation of line in space which is passing through the point and parallel to the given vector, let us consider the three-dimensional space. This is x, y and z axis. Let us consider a line which is passing through the point A with the position vector vector A and another point and parallel to the given vector P. Let us consider another point P with the position vectors vector. So here we have to give the explanation for this figure. Now let us directly derive the formula. The given line L is given that it is parallel to vector B, then obviously vector AP will be parallel to vector B. That means we can write vector AP is equal to lambda into vector B. Vector AP is nothing but OP minus OA, that is equal to lambda into vector B. Therefore vector R minus vector A is equal to lambda into vector B. That means vector R is equal to vector A plus lambda into vector B. So this is the vector equation of line. Now move on to the 38th question, which is based on the probability, that is mainly on base theorem. They have given there are two identical boxes. Let us consider E1 as the event of selecting box 1. E2 is the event of selecting box 2. And A be the event of drawing a gold coin. Then the probability of E1 is equal to probability of E2, which is equal to 1 by 2, because there are two boxes and selecting each box is 1 by 2. Now we have to find the probability of A given E1, that is selecting gold coin from the first box. There are two gold coins out of 2, therefore the probability will be 1. If we consider probability of A given E2, that is selecting gold coin from second box, then we get the probability as 1 by 2. Now the question is, we have to find the probability that the coin in the box is also a gold coin. That means if we are drawing one gold coin, the other one is also a gold coin, which means we are selecting box 1. Only box 1 contains 2 gold coins. Therefore, we have to find the probability of selecting first box when we already know that the drawn coin is gold coin. That is nothing but probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. If we substitute the values, we get 1 by 2 into 1 divided by 1 by 2 into 1 plus 1 by 2 into 1 by 2. That is 1 by 2 divided by 1 by 2 plus 1 by 2. That is 1 by 2 divided by 3 by 4, which is nothing but 2 by 3. So this is the solution of the W. This is all about part C questions. Let us discuss part D in the next video. Thank you.